Yeah, good evening, everyone. Or good afternoon, is it maybe in, Spain still, but yes, that's good. Um, my name is Menno. We are going to do a workshop on materials, the materials people use to sit on when in wheelchairs. A workshop means for me that you have to do the work and I can just sit on the table and relax. Is that okay? Yeah. No. Huh. Typically. So how are we going to solve that? Well, to start with, in the program, there is a small mistake somewhere because it says something like this, wheelchairs and stuff. And that is correct, I did that last year. This year, the intention was to talk about this. That is, we're going to talk about what happens in tissue when it is loaded, so when you're seated on it or when you're laying on it. What happens in a material when a material is loaded, and how can you combine those two things? So when I talk about material, I talk about seat cushions, I talk about mattresses. That's the stuff. Is it okay? But we have no misunderstanding on that. The first picture was, as a matter of fact, 3 weeks ago, Norway, still so much snow. It was delicious. Really nice. I loved it. But I have to admit that I was outside for an hour now, and it was even better. For those of you who want the slides I make a PDF of it when we're done. You pick up my card, send me an email, and I'll send it to you. Okay? Good. That is also then done. Then there is no questions about it and all that stuff. And I put my alarm on 10 to 6 so that I know when we have to finish. Good. Yeah. What was my first slide? All remember this guy? All of you know that he died of a pressure ulcer and all that stuff there. And in my normal seating lecture, I have a nice thing where I ask the question, can you tell me why he got a pressure ulcer? Can you tell me why he got a pressure ulcer? Wrong position, absolutely. The guy is sliding out of the chair and he's asking for problems. Right? Simple. Piece of cake. But the whole main question is, how can we prevent this thing? And when I go around here on EWMA, and I hear a lot of people talking about prevention, they talk about how many pressure ulcers they have in nursing homes, that's an average between 15 and 25%. They talk about how many pressure ulcers they have in hospitals, that is an average between 15 and 25%. They talk about all those kind of things, and they don't know what happens at home. And for me, the simple, I only work with prevention. I'm a physiotherapist, and for me, the important thing is, what can we do to stop this pressure ulcer to happen? For 10 years ago, I worked for a company, and that company was on advice or demand from the American Medicare. It was an American company. American Medicare, so that's the insurance company, they said, we are not happy anymore with that every company selling seat cushions or mattresses state a lot of things, and every mattress, from the cheapest 10 centimeter foam nothing mattress to the exclusive 4,000 euro mattresses, they do exactly the same. And they said, cut the crap, prove it. So at that time, ISO, so the International Standard Organization, alliated with Medicare and with some of the main providers or producers of these kind of cushions, and started to ask 3 or 4 different American universities to do a test program. And they agreed on doing this test on pressure, on shear, and on microclimate, so the heat and humidity. And they said, we are going to make ISO standards out of this. And I became involved in 2004 about, and then I'd been working with that for 1 or 2 years, so that's just 10, 11 years ago. One test is done. That's the microclimate test. Published last December, I think. The rumor said it was published. I think it is published. The other test, as in pressure, it's at a standstill because they cannot prove it. And the third thing, shear, is impossible to prove in materials. It's difficult to prove. It's even difficult to prove in the body. So this is a little bit of background, my background in this story. So I was running behind all those researchers doing these stuff, and you got first-hand information, and it was really fun, and we thought we knew it all. Until 2006, then there was a Dutch guy who said, we have now proven that it is not the lack of oxygen killing cells. So pressure, we think pressure, you squeeze the skin. When you squeeze the skin, you squeeze the cells in the skin, the oxygenation is stopped and the cell dies. Correct? Well, no, it's not correct. It's not happening. It's not that what is happening. Do I have to point that way? Yes. We know this. Yeah. So, next one. In the old days, I mean from Hippocrates to Florence to anyone, they thought it was something with not enough nutrition into the cells which kill the cells. It does not cause a pressure ulcer. In a newer time, in the 30s, they said it is the capillary pressure. So we need to have a capillary pressure over 30 millimeters or 32 or 37 or 30 whatever millimeters mercury, and then yes, the cells will survive if the pressure is lower than that. Nonsense. Nothing to do with the case. We have a lot of other stuff influencing this. And you all know Sina Moore probably, and Sina Moore has a beautiful slide of a young lady. She's married to a football player, and he's been in America for many years. He's British. What is his name again? Beckham. Right. And his wife is the most skinny, scary, skinny person you can imagine. Right? And she always says, when you don't have enough nutrition, do you get a pressure ulcer? Well, Mrs. Beckham is the example that you don't. And I think it is a great one. I think it is a great one. Oh yeah, it could be an additional thing, but it is not the main cause. You never get a pressure ulcer because it is not because you get wet. It is not that you don't eat. It is not that you are old or have no sensibility. But the thing may be on how much you move yourselves could be really important, so that the pressure goes over certain levels. What Kees Omens from the Technical University in Eindhoven, in the late 80s, as a young student, he said, it is strange, but muscles can survive for more than 26 hours without that they get oxygen. Muscle cells. They are not happy, but they live for 26 hours. Oh. Then everybody says, oh, he's just a stupid student. He doesn't know what he's talking about. He's now leading a big group of people working on this. And in 2006, one of his people proved that it is, as a matter of fact, cell deformation which does the job. So now we are in Spain. Any Spanish here? Yeah? If you think a balloon, a big balloon, do you think a big yellow balloon or a big red balloon? Because in Norway, we think of a big blue balloon. And in Holland, I'm Dutch originally, in Holland, we think of an orange balloon. Right? So my question is it in Spain, is it a red balloon or a yellow balloon? Yellow? Red? Okay, it has a color. It has a color. Imagine I have a big balloon in my hands, right? And I take this big balloon and we squeeze it. So we take a plank, a piece of wood, on the balloon and squeeze it down. What happens with the balloon? Sorry? It gets wide. It gets lower and it gets wider. But what happens to the color then? No. Because if you squeeze it down just before it breaks, the trick is not to break it. Right? Just before it breaks, you see that the color in this flat area gets whiter. You've all seen it. You've all seen it. And that exactly happens also in the muscle cells. That means that when you squeeze a muscle cell, the muscle cells will widen and the membrane will open up. You get a change in osmosis. That change in osmosis, and Kees Oman says it always so very nicely. He says stuff inside the cells is squeezed out, and maybe stuff inside the interstitium is squeezed in. But both situations are really bad for a cell. They die of this. They die of it. And if you use too much force, so you really bump down in a chair or on a concrete surface or whatever, these cells will die immediately. And if it takes another service, any type of service, it takes 2 to 4 hours and then the cell is dead. Then the cell is dead. This has been proven by Omans in different studies. It has been proven by Geffen from Tel Aviv in the same type of research. And they say, well, Oman said it the other day, 2 years ago. He said, we don't believe it is like this anymore. We know it is like this. We know. Funny. Any comments on this? It is in a way shocking. I remember when I was studying physiotherapy in Amsterdam, we had a summer holidays and we came back at school and the teacher comes in and says, everything you've learned about this and this subject, forget about it. All the theories you have been studying the last 2 years, forget it. You're now going through a crash course in learning things how it really is. I think they have done that exercise now 10 times. 30 years ago that I stopped studying physiotherapy, but finished my studies. But you know what I mean? We all have learned that it is something with oxygen and cells die and blah, blah, blah. It's not. It's the cell deformation what kills the cell. And that means also that we have to think different in how we act, how we start to prevent, I think. There is also another problem. When we squeeze a cell, I love to do this with young ladies. I'm going to squeeze your cells. May I use you, please? Oh, thank you. So, I'm going to squeeze her cells. So now I squeeze her cells. The cells in between my fingers, they say, Menno, you are a nasty bee. Remove your fingers because we are without supply, nutrition. You all agree on that? Yeah. And you know what these cells did the moment I took them? They said, we are going on anaerobe. The same second you squeeze a cell, it says, I am going on anaerobe. And I'm going to live happy forever after. The problem is though, because I continue this squeeze, the, what is it called, the waste products, what do you call it again? Suffocate the cell. And that process takes between 2 and 4 hours. But the main cause of cell death is deformation and membrane deformation. Good, nice. Both Israel and Holland have said there is a loading or a deformation threshold. And if the load, so the pressure your body weight does on these cells, above a certain level, the cells will be damaged. But also, there is a time factor in this. And in Israel, they made this very nice picture. What you see, and I don't know if there's an arrow or a pointer here. Is it a pointer in this? Is it a pointer? No, it's no problem. I'll show it. What you see, this is pressure. So they also say, forget about these figures, the 200 millimeter quicksilver, because you can't show that deep inside the muscles. You can show it in the skin, or on top of the skin, but you cannot show it deep inside the tissue. And by the way, I didn't say that. All wounds happen between the bony prominence and the muscle. They do not happen in the skin. Pressure ulcers are not a skin problem. They become a skin problem, but they are not happening in the skin. So you have a certain amount of pressure, you have a certain amount of time, and at a certain moment there is an intolerability. So if you have a lot of pressure, after a short time your cells will die. If you have a lower pressure, it takes a longer time, but your cells will die. If you have a very low pressure, they may survive. They may survive. I had some questions down there. Does the time dependence of tolerance relate to cell level processes? Does the decrease in tolerance relate to the mass transport phenomena in cells? So, what they did in Israel and in Holland, so in the beginning, you see the little drawing on the right-hand side? That's a rat on his belly, and they're pushing a structure on the whatever, gluteal muscles or whatever of this rat, and they see that it is deformated and dies. Those were the first tests. And they made tissue engineering tests of materials, of muscle cells, and they started to test how much pressure and time do you need to kill these cells. And they still do it. But then, now they make it also on tissue that is damaged, as for example, a guy who has a paraplegia or anything like that, and they're seeing, okay, those muscles are different from normal muscle structures, so what is happening there? This was at that time the hypothesis, and today they say it is true. So you have an immobilization, you have a tissue deformation, cells are deformed, membranes are stretched, permeability is changed, and concentrations of the materials are squeezed out of the cells, the cell will die. This is a nice picture, I think. It is so easy that even I can understand it, which I think always is I'm always happy when I understand things like this. Sandra Roeracker, Dutch, one in Omen's team. She tested in 2001 different things, and one of the things he said, it is important to minimize the tissue deformation by means of cushions and mattresses with appropriate stiffness. What is appropriate stiffness? How long time can a cell be deformated before it gets dead? We have an answer on that, but still. On what kind of material? And how long time does it take when we take away the pressure before the cells start to act normal again? What she also said, again, I'm trained as a physio. As a physio, we learned if you have a paraplegic or anything like that, and this person is seated in the chair, I'll do that here. No, I can't do it there. There's a table there. I'll do it here. I am seated in a chair, so I have to, from time to take my arms on the armrests or whatever. I have to lift my behind and shake it out, and then I can sit down again. We've all heard about that exercise. And what Sandra Roeracker in effect says is, nice try doesn't help. And I think, oh gee. All we nice physios and nurses and etc. have told the people that just lift your behind, shake it, and you're happy again. Not true. it had no difference. A 2 hours continuous loading and 2 hours intermittent loading had no difference in result. Cool. Really cool. Or maybe not so cool. At EWMA last year, there was a American guy representing some people from Long Island, and they were all together. All the people doing this research were plastic surgeons, and plastic surgeons, they have ultrasound machines, and these plastic surgeons had on something like 60, 70 people taken ultrasound of what were suspected stage 1 or category 1, 2, or the American DTI, deep tissue injury. We know there is something and you don't know what it is. It hasn't opened yet. And they had a very, very clear line. This is a sacral area. You see a stage 2 wound with blisters and stuff like that. This is a normal sacral area, and this is the sacral area of this patient, where it says that it is a loss of interface and hypoechoic lesions. I don't know that language exactly, but I know that is wrong. That is wrong. And this is a stage 2. And in stage 1 you had more or less the same thing. And the conclusion of this nice little research is that whatever we say and do, when we say, oh, it is a stage 1 or a category 1 and it is not so dangerous, just wait a few days and the redness will disappear, it is a wound. And it should be acted upon as a wound. That is the full, it's the wrong word probably, the full Monty with pressure redistributing devices, etc., etc., flat on your stomach, all that kind of stuff. Quite serious, isn't it? Because I have that at least that idea, and I've asked many people, and we go all around with this idea that it's a stage 1, so it's not so dangerous. And I think we have to change that habitual way of thinking. I think we have to think it is a stage 1, it is a wound. Act upon it as a wound. This is the research thing. There is more research needed kind of thing. Right? My challenge to you, any doctors here? Medical doctors? Good. Any of you having a ultrasound thing in at your disposition? If not, you have certainly a colleague somewhere around. Ask them. I have this patient with a suspected stage 1, stage 2, or whatever it might be. Ask them to do an ultrasound and see if you can confirm this, just for yourself. And if you have confirmed it, send me an email, my card is here, and please come to situations like this and tell people about it. Because we are not really enough aware that a stage 1 is a stage 1. Principles of pressure redistribution. That is the second thing we are going to talk about. So, time is of importance. What they said is between 2 and 4 hours the cells will die if you are on a nice material. My question has been to Kees Omens and to Amit Gavin, and how long time does a cell or muscle structure be without pressure before it gets back to normal? And they wanted money to get that answer. I don't have that money. But maybe one of you working for a nice company can invest in that money. Right? The main question we have to ask. I showed this little list of incontinence and nutrition and all that stuff. But the main question you have to ask yourself and the client and the nurses around the client, can the client turn himself around adequately? Yes or no? If there is a yes, the no is the other one. If there is a yes, do something else. Use your nursing time for better things than examining the patient. If there is a no, use your nursing capabilities and ask to do the follow-up questions. And start preventive measures. And with preventive measures, what do we mean by preventive measures? This is a workshop, you know. You have to talk. Equipment. Very sure. What more? Encourage person to move. But grandma can't turn herself around anymore because she had a stroke. Take care that someone is turning around this patient at certain intervals and more often than you're really happy about. Those are the two main things. And then, of course, you have to do the other things. That is incontinence, that is nutrition, and that kind of things. But you have to check. In British literature, it is, or in English literature, it's called the skin bundle. S is for, and the S is for, so it is SSKIN, right? It is service, it is skin. The K is for, the I is for, N is for. You were born with it now, isn't it? It is really good because you have to do this. And you have to do it regularly. But you have to ask this question first. You have to ask it. Can the patient turn itself adequately, yes or no? And is it a no? Start working. Do your skin bundles, do your husky in Norwegian, do whatever you want to do, but take care that this patient is kept moving. You have to do a risk analysis of what kind? Some kind. I think it is also beautiful. It is so nice to see. In the UK and in Ireland, you have to do a risk analysis at admittance. Beautiful. I am going to operate it in my ankle. So I walk into the hospital, I sit down, and the nurse comes in and says, we have to see your behind because maybe you have pressure ulcers and stuff like that, right? And then I'm operated. Something went wrong with this operation, so I'm laying on my back for 3 days. But they have done a risk analysis and seen there's nothing wrong with me, right? But after those 3 days, maybe in coma because something went wrong, I might have a problem. I mean, I'm an old guy, I'm soon 60, so things can go wrong. A risk analysis is like fish. You have to refresh it. You have to do it. You have to do it often. And a physical examination is not asking the patient. I have seen so many paraplegic people asking, have you ever had a pressure ulcer? No. Never. And how much time does the nurse spend on you every morning? Oh, she uses half an hour every third day. On what? I don't know, she's doing something. It is so often. It is so often. You see it all the time. Pressure redistribution, that is now the interesting thing. That's what we're going to talk about. So what is materials and how can you use materials? Oh, treatment. that is when the rest has gone wrong. You haven't done your job. Right? I think that is also a thing. You have to imagine that nurses, I see as a physio, and this is dangerous, this is really dangerous. I'm going to say something really dangerous. I think that wound care or pressure ulcer prevention is a nurse job. It is care. That is a nurse job. It's a nurse's responsibility. They shoot the doctor, but it is your responsibility, right? So, so when you have to treat a pressure ulcer, and this is the dangerous one, you haven't done your job. It is a dangerous one, I know. It's not high enough for you to die, so. When you throw me out of the window. But seriously, someone has not done the job when someone gets a pressure ulcer. And we have to start realizing ourselves that a pressure ulcer is not a thing just happening. A pressure ulcer is because. And the treatment is because. But I know nothing about treatment, so I'm going on. I still love this drawing. I have to use it in every slide. Pressure is that your body weight squeezes the soft tissue between what you're seated on or laying on and the bony prominence. And I love these words. One of the lectures I was in, someone was again talking about pressure reducing materials. And I think this must be every woman's dream. Think that you're going to sit on a cushion and instead of weighing 60 kilos, you're only 45. That must be so lovely. I love those cushions. Anyone working with those kind of cushions? Nobel's Peace Prize. You're going to save the whole world, all the women in the world. That when someone is laying on your products, they get lighter. That is good. But you're going to have problems in defending that thing. Try to explain me. I'm 90 kilos. Not true. I'm 98 kilos. my goal is 90 kilos. My goal is 90 kilos. Okay. My goal is to be 90 kilos, and I'm 98 kilos, right? So I'm going to lay on a bed, on a mattress, and when I'm laying on this mattress, you are saying that I'm going to be only 90 kilos.
That doesn't go that way at all, because it depends how your immersion and envelopment properties goes into the mattress, and it depends on the surface which is contact, surface of your body which is contact into the mattress, and that defines the average pressure, and therefore depending on the mattress materials, it also defines what are the peak pressures, and that defines what are the tissue properties and what is happening with blood flow, and what kind of stress the cells suffer from, and what is the tissue stress, and what are the temperature changes in the skin and the
Yeah, you're completely right. But then it is so that your products do not reduce the pressure, but they redistribute the pressure over a larger area. That is the word. In a nomenclature around pressure also redistributing devices, they have taken away this pressure reducing stuff. the word pressure reducing, because you don't reduce the pressure, you redistribute the pressure over a larger area. And it is again that we are getting a little bit aware of how do we say things and what kind of impression does that make what we're doing. Oh, you've got a very nice cushion. It reduces the pressure. No, it does not. But it distributes it, it divides it over a larger area. That's where the things are happening. Where's my contact thing? But it doesn't reduce the weight. It doesn't reduce the load. The load is identical. It could be that it does. Not all materials do that. Shear forces and friction, I'm going to define this a little bit more later. But shear is that you put tension on your soft tissues. So it is seated. You all can create shear here now, you know that. Right? The easiest exercise is that you're going to sit on your hands. Right? You're sitting on your hands. Do it. It's a workshop. Come on, work. Sit on your hands, lean backwards and lean against your backrest and feel that your skin is still on your hands, but that your pelvis has been sliding forward. You feel that? Right? At that moment, you put stretch on your soft tissues. That is shear. Some call it shear forces, some call it shear strains, but that is shear. It's a simple exercise. Friction is something completely different. We go back to that in a few minutes. And then we have the microclimate thing, where I'm not sure yet what the conclusions is going to be in this EWMA group working with microclimate, in how important microclimate is for the development of pressure also. So how important is the microclimate for cells are dying. Stephen Spriggle, he is one of the guys who learned me a lot about materials and material science. He is a professor at Georgia Tech, and Stephen took these pictures in an MR machine. So this is on the left side the hanging person, so the buttocks lifted up, seated in an MR machine, and on the right side the same person seated on a foam cushion of certain qualities. And what you see is that the red area, so the muscle tissue, is really deformed on the right-hand side picture. Right? And this is the deformation stuff. Redistribution is to redistribute it over as large as possible area. So the bad way of saying this, laying on one nail is something completely different than laying on 10,000 nails. Right? And then the wording they use today is the words immersion and envelopment. Immersion is to sink into a material. And envelopment is how the material envelops your body, surrounds your body. If you are seated and you sink into a material and the material is too soft, you will bottom out. If the material is too hard, you will sit on top of it. Whatever material you have, you will sit on top of it. And the whole trick with all these cushions and mattresses, etc., is to find that you immerse just enough. And there is a conclusion there. There's a thing you have to think of. Because the higher the material is, the more you can immerse. The lower the material is, you cannot immerse. And if you can't immerse much, you will also have a higher feedback from the material. Because you don't want to bottom out. You don't want to bottom out. Spriggle defined envelopment as capability of a support surface in deforming around and encompassing the contour of the human body. So the ability to encompass and equalize pressure. And I always have to state, it is not me in a dead sea there. Yes, I'm sure. I have more hair. I'm not that bulky. The picture on the right-hand side shows very nicely what is meant by being encompassed. If you're laying in water, if you're laying in air, floating in a material, you will be encompassed. That has really a nice and good effect. So I'm going to talk about the materials. And now it's going to get fun. Now it's going to get fun. Because what is a foam? Can any one of you explain me what a foam is? And not in a 5-minute lecture, but just in 2 sentences.
It's a combination of many materials which are formed in a pressure together with water to form breaking bubble material.
So what you say, it is air with walls around it. That's what he said.
Not water, but material.
Yeah. It is air with walls around it.
It's a broken.
Can be broken. Can be round cells. Can be anything. You have even Cole, he did that's also an American, he did a research on materials in American cushions, and I think he came to 40-something different materials used in foam cushions. So different kinds of foam.
They are thousands.
I know, there are thousands. But just the main cushions on the American market were 40 different types of foams. And all had perfect pressure redistribution qualities. I love that. But what we know best in most European countries is the cold foam, or it is the viscoelastic foam, tempur kind of foam, right? And then we have the fluids. That is the airs and the oils and the gels, as long as it is fluid. A non-fluid gel is something completely different. It is water, etc. What the likeliness is for all these foams is reaction forces. The moment you put a load on a foam material, this foam material will react with that I want to go back to nil. I want to go back to nil. That's where I want to be. The moment you squeeze a foam mattress, the foam mattress wants to go back. And what you get is that you get the highest pressure where you put in the most pressure. You understand me? Yeah? That is just to make it visible. I'll explain a little bit more about it in the next slide, but with fluids, I had a video, but I managed to blow it. And the video shows you a bucket of water. You take a ball, push it down in the bucket of water. What happens to the water? Increases in height, right? So the more you push the bucket down, the more the water gets up. And that is a little bit the thing with fluids. Fluids have to have the possibility to get out of the way. To get out of the way. And if fluids are not able to be squeezed away, dispersed, you have a problem, because then you get a reaction force. Does that sound difficult? It's going to be easier afterwards. So what you see here is foam cushions, and you get the compression stretch. And I'll try to explain the compression stretch. What you see here is a microscope or an electron microscope picture of foam. some kind of foam. It is an open foam type. And you see all those cells around here, and you have to imagine the moment you start loading a foam, this foam, these walls, these cell walls, will start to stretch. You've all seen it. You sit there, you have your hand on a foam thing, and you see the foam is squeezed together here, and it's standing like that there. And in that area, those foam cells are stretched. And this stretch does also that these foam parts want to go back to where they were. Okay? And the more you move this, or the more you load this foam, the more will these cells break down. The walls will break. And after a while, foam will start to disintegrate. How long this takes is depending on what kind of materials you have put into it and how well the chemical composition of these materials are. But it will happen. Other things like ultraviolet light, temperatures, humidity, feces, urine, all that kind of stuff will help to disintegrate the foam. So this process with disintegrating will happen. In Norway, a nurse has done a little investigation by asking her students, take pictures of your foam mattresses. And so Norway is a rich country, but they spend no money on mattresses in hospital and nursing homes, not at all. It is not used at all. And many of those mattresses were between 15 and 20 years old, foam mattresses. A normal foam mattress has 8 hours per night sleep, could do it maybe for 3 years, 4 years, then it is dead. These high quality foam mattresses, which often are a little bit thicker, often have a little bit better chemical, properties, they may live maybe 5 years, but maybe not even that. Foam mattresses die before you know the word of it. Before you know the word of it. Back one. Imagine now, you have a foam block. You call it cushion, or you call it mattress. And what you do is you take a knife and start cutting in the foam. Maybe like that too. The moment you do that, you reduce this tension, this internal tension in the foam. So you start loading it, those cells get stretched because you have cut into the foam, the stretch will be less. You understand that? What is the disadvantage of doing stuff like that?
It reduces the duration of the flow.
Absolutely. And the second one? You will sink deeper into the material. So there is more chance that you will bottom out. You get that? Yeah? Good. Not bad. It's, what is the time? Oh, not too bad. So, split foam is softer, it has less tension, and you may bottom out, and it will die even quicker. I'm not going to talk about foam qualities as in kilos per square meter. That is maybe a little bit too technical for this audience, but if you go to a sales rep, you're going to buy a new mattress at home. You know what a sales rep will tell you? This is a very good mattress. It is really a good mattress. It has 25 kilos per square meter foam. Okay. Okay. I know mattresses who have 80 kilos per square meter. That is a lot. The cubic meter, I mean, not square. The way they make foam is they put together all those chemicals in a big tube, and they make a street 60, 70, 80 meters long, 4 meters wide, 4 meters high, and out comes this bubbling material. And when it has come out, they take a knife, cut it into pieces, right? Nice blocks, pieces, and say, this is your mattress. And when they make small pieces, this is your cushion, right? Or they make cushions that they have a form, a shape. What's it called again? Template? Not a template. What is it? A shape. And they put a little bit of this chemical substance into it, and it comes out like a nice cushion. Right? That's the way to do it. The difference between viscoelastic or tampoo materials and foams is that normal foams, so cold foams and those kind of things, they have rounded cells. Viscoelastic has 6 or 8 sided cells. The thing is with viscoelastic, if you put a load on it, you need either temperature or weight to have these shapes to collapse. And they will collapse. And then the foam will shape itself more according to your body. You copy me? Yeah? That means that if you're on a viscoelastic mattress or cushion, the cushion will, after a little while, shape itself towards your body, according to your body. That's really good. That's really nice. And when you then leave the cushion or the mattress, it takes a while, no pressure and lower temperature, to pop back to normal. That is viscoelastic. Has its advantage, it has a good environment, and has a disadvantage. It retains heat and humidity, and it is really difficult to move. Types of how to split foam. If you have a fluid, so air, water, fluid cells, oil, whatever, you need to think the bladder or the container. Think that I have a plastic bag. I have a plastic bag, a big plastic bag, big plastic bag, big plastic bag. And I fill the plastic bag with whatever, air, right? I squeeze it together. I put my hand on top of it. What will happen to my hand? No. It's filled with air, so it will stay on top. But if I let air out of the system, I can go inside it. And my hand will go inside. And the more air I reduce into the container, the more my hand will be into the thing. So with air, it is important, or any fluid, that the bag should be significantly bigger as the contents. You understand that? So if I have a small airbag and sit on it, I will just sit on it. But if the airbag is really big, either with that I have made slices in it, or that I have made a really big bag, I can sink into it. Then the air, the fluid, can disperse. It can move to the sides, and I can sink into the material, and I will be enveloped. And envelopment is, as you stated really correctly, it does that your average area is getting bigger, and you will reduce your peak pressures, which is important. So the more you have segmented it, or the bigger you have your bag, is important. This thing was published by Geffen in December, and it's nice to know people, because then they say, yes, you can loan this thing, please use it. What it said, what they have done, so they have made these MRI pictures, and the MRI pictures, they show, as I showed before, that you have a squeeze of the foam, but what they also show that you have a squeeze in the soft tissue. Right? That's the squeeze in the soft tissue. They have translated that with these meter-long mathematical ways of calculations and stuff like that, how you can translate that to the deformation they've made in those cell structures they made, right? So they can translate what they see on the picture into what you have in those old cell things. And they can see how the deformation is. And what they found out is that if someone is seated on a foam material with a certain firmness and a certain quality, etc., you have a certain time limit before you go over the threshold line, and your cells will die. And this research was paid by Rojo, and if you're seated on a Rojo cushion, you have a totally different picture and a longer seated time. Still not so long that you get under this threshold. We can't get under the threshold, which is a pity, which I hoped for. But you can't. Interesting, isn't it? And I think there are a few manufacturers here. And I would say to you guys, please take your products to Gavin, pay him a few dollars, and ask him to do the same thing on your materials and publish it. Because then we can start to compare stuff. How does product A function compared to product B? Then we can get this thing that when people state, my thing is better than everything else because, you get the thing that, yeah, we can see, it is better. Or no, maybe it is not that good. Or maybe it is, as a matter of fact, crap. And those products that are also out there, crap products. I mean, in 2005, with the tests they did at that time on pressure redistribution, you had products which were sold as being the most expensive products in Europe, and they were the worst products you could put on a human being. Was the test they did at that time. Really interesting. But if you don't have mattresses or whatever kind, you have to think, or cushions, you have to think, how high is it? In my seating thing, I have a little lecture on when you are seated, there's a high difference between your thigh bone, your femur, and your IT, ischial tuberosity. What is the height difference? Any suggestions? You have to tell me what how many centimeters or inches it is, and then you have to tell me if it is for a male or a female. Any suggestions? 5 centimeters. Male or female? Male. Okay. And what is the female then? Wow! Wow, that is good. That is really good. Are there any other suggestions? Are there any other suggestions? Seldom that I have such a good one. Any other suggestions? Dutch OT did a research on this in 2004, 5, 6, something like that. She found out with Germans, Dutch people, Brits and Swedes that the average height for males was about 6 centimeters, between 6 and 7 centimeters, and for females between 7 and 8 centimeters. That means that when you are seated on a cushion and you're stating that this cushion has a pressure redistributing quality, you have to think height. You can't put someone on a 2-inch or 5 centimeter cushion and say, you're fine, it's good with you, it's no problem. The manufacturer said it's a good cushion, so you're good. You have to think height. You have to think at least than the same height as this, and probably a little bit more because you want something under the person. Think height. So there were two remarks. The one is that if you put someone on a high cushion, it might happen that the feet are hanging in the air. And the feet hanging in the air is the worst thing you can do with a seated person. So you have to take care that you do something then so that the whole configuration of the chair is in a such way that you have contact with the feet on the floor, or a footplate or whatever. The second thing you said is that when you have high thin cushions, many people feel insecure because you get a kind of instability. And that I want to say, it is depending on what type of materials you've used and how you've used those materials. But you have to think height. And you have to consider that every time you get an enveloping product, this product will automatically give you some kind of instability. Yeah, it does. It does. Later. So you have to think height. You have to think that you have to segment it, and you have to think that you need to have a lot of surface area. So the bag should be considerably bigger than its contents. That is the important thing. If you have an alternating pressure thing, you have to think that if you are on an alternating product, and I think alternating products are going to disappear. Seriously. I think they are going to disappear. And the reason is that if you're laying on a surface and you're saying that now we're going for 5 minutes to take away half of the surface. And then we take half of the surface up again and take away the other half of the surface and take it up again. And in the old days, when we thought that it might have been blood flow and those kind of things doing good, we know now that that is not the problem. And you don't stimulate blood flow with those machines. So you have rather to think that the whole area needs to be a supporting surface the whole time to get an as large as possible area to lay on. That does the good thing. The blood flow has nothing to do with pressure ulcers. Or you have to think the 1 in 3 system, some which companies have, or the 1 in 4 systems which some companies have. So then you're only taking away 25% with the 1 in 4, 25% of the surface area. And then you put it back again, and you take another 25 away, and you put it up again, and you take another 25 away, and you put it up again. And that is the fun thing with these things. We think with systems which were made in the 50s and 60s with totally different theories behind us, and I think we have to rethink. We have to rethink. Low air loss is a nice thing, but the only thing it does, it blows air into it, and I don't know what kind of effect it has on pressure redistribution otherwise than it takes the humidity away, which is a comfort thing. So, you have to think material split, that is envelopment. You need to envelop into the product. That is the main thing you have to do. The thickness does that you can sink deeper into the material, you get a better envelopment. And with the fluid materials, you have to consider that the bag has to be really, really big to envelop your body. Then it does work. So it's surface area. Spriggle did this one too. I've asked him if he can do other things too, but it's again the money question. Who's paying for it? He did it by himself without any companies in between. You need, with all materials you're seating on, all materials, you need to do a hand check. So you need to check between the patient and the surface area to do a check how much material is it. If it is foam or anything, you have to do it. And again, my experience is from Norway, where in the hospitals they often have 10 minutes left, where often they have only 10 centimeter foam mattresses, 12 centimeter foam mattress that is this thick, and people are laying on that for 24 hours a day. You need to check. And those mattresses can be 15, 20 years old. You need to put your hand in between. Is there any flexibility in the material? Whatever mattress or cushion you have, put your hand in between. is the flexibility. No flexibility, make another choice. Do something about it. Shear. You slide down in your chair, you stretch the soft tissue. That's what you tried earlier. Imagine, you have your pelvis, you have your ITs, you have your soft tissues, the muscles, the meat, right? You sink down into the material. And when you sink down into the material, this material will stretch around your ITs. This stretch gives you the pressure also. Yeah? That is also shear. That is a shear strain. You cannot measure that. Yeah, maybe Gavins and Omens can measure it in their really advanced systems, but you and I, we can't measure it. That is tissue deformation as it was before. Friction is something completely different. I need to run again here. I wanted to use your arm, but I'm going to use your arm this time, because I'm going to show you the difference between friction and shear. This is shear. This is friction. And you don't get a pressure ulcer superficial in your skin. Or you can have a damage there, but it is not a pressure ulcer. Thank you. You understand me? Right? So everyone talking about, yeah, we have to avoid friction because the pressure ulcers and stuff like that. Nonsense. I do agree that you need to reduce friction when you do transfer or whatever. Those who are going to get these slides will find this one. Read it. It's nice bedtime literature. Technical people. Again, split the material. And you know, when you split the material, you will move with the material. That reduces shear. Right? It will follow you. So the more flexible the material is, the better it is. Again, the size of the container, because is the container big, you can move your body around. It moves with you. You reduce the shear forces. I don't know if it is the next slide. Yeah. Every time you do a transfer of a person, and these persons with the pressure ulcers, it's you doing the job. You need to turn them. Every time you turn them, when you have turned them, no, I say it in a different way. I say it in a different way. Every time you turn around in bed, right? So you're laying on your left side and you're turning around on your right side. You do it in a certain way. That's the way we use when we teach people transfer techniques. How you do that? No time to talk about that now. But when you turned yourself around and you're on the other side, you do one specific movement. Right? Yeah. Everyone does. Everyone does. But when you have turned your patient, you don't do that. And then the patient will start complaining. Because when this patient is turned, now I'm going to use you. Good. This is a workshop, right? I'm a physiotherapist. We used to touch people, so I'm touching you. All right? And every time you turn around and you have turned the body, this skin is on tension. And that is really uncomfortable. So you have to do something with this tension. And so you turn a person, you need to slide your hand under the body in small movements, and then the patient starts to smile. So you go this side there, that side there, that side there, that side there, and the head, and the patient say, thank you. And it is so funny to see. Every time you do it, these patients will smile and they feel happier and the complaints will be reduced. And you still have to turn them again after 2, 3 hours. 4 hours is a very long time. This part I'm a little bit uncertain what is going to happen here. There is within EWMA a group of people working with microclimate and looking in how important is it still. Anyone been on that meeting in Southampton? Have you been there? Have you been there? What did they say?
If I summarize that 1 degree of temperature increases or decreases metabolic demands by 30%.
Yeah, we know that. That is what Coquette said. But is that still important to prevent pressure ulcers? That is the good question. It is still important. Good. Happy about that. Because then you have to think that if you're seated in a wheelchair and you have a sensor on your buttock and you have a sensor outside the buttock, so between your body and the wheelchair, you will see that the skin temperature and the interface ambient temperature will increase. As soon as you sit still, you go from 24 degrees to 34-ish. As soon as you have a movement, the temperature will decrease again. Done by Avon Cole, 30 different people, same result. All those people. For me, the conclusion after this was that, hey, if temperature and humidity is important, keep that person moving. Or blow air under the patient. Or do anything to keep the temperature down. So then low air loss or systems like low air loss can be interesting. Understand? 1 or 2 more slides and then we're done. There is a new ISO test coming up. That ISO test is going on this stuff. I don't remember the number. Probably going to be approved now in May, somewhere where people are going to meet. Paris, I think it was, maybe Berlin, where they are going to check how a material reacts on increased temperature, increased humidity, what happens to the quality of the materials, and what influence do body fluids have, feces, urine, and stuff like that, right? And on the materials. We jump over that. No, we don't jump over that. So in foams, in general, the more close-celled the foam is, the more heat and humidity is stored. If you have an open cell, it is easier to get away. If you split it up, it is easier to get away. Turn the patient often to reduce the heat and humidity. Viscoelastic, as the viscoelastic materials, so the shampoo materials are made today, they are close-celled materials and they make you warm and sweaty. They make you warm and sweaty. So you have to turn the patient often, even though it gets a lot of, it does a lot of encompassing and that way a good job. Air contains heat very, very short time, less than 30 seconds. But it is the type of container which decides the humidity. So what kind of plastic is it made of? How long the humidity stays. Oil is heated, and oil keeps the heat or the cold for a very long time. But again, think split, change position, and keep granny moving. That is so important. Keep granny moving. The last things, repositioning, not going to talk about it, but it shows that you reduce the amount of pressure ulcers by doing repositioning. The 30 degrees tilt is much better than the 90 degrees tilt, even though it is very difficult to position like that. There is a poster up there made by me about things like that, how you can do a positioning. And you have to think also this, when do you choose which mattress? Is the patient at risk yes or no. Does he have a pressure ulcer? Stage is not important. Any danger for shear forces, so skin hanging there, or setting, what is it called? Yeah, that you get shear. And how warm and sweat is the patient. Understand what kind of materials you put patients on. Be critical about what people say, also about what I say on materials, and ask questions. Does it give envelopment? How does it give envelopment? Because envelopment is the important thing. This is just an overview, so those of you who get my card will get this, and think skin bundle. Look at what they did in Wales and many other trusts in the UK by the reduced pressure ulcers to nearly null, really null, by simple means. Stop pressure ulcer day. When is it this year? 20th of November, the third Thursday in November. We're going to organize stuff in Norway. This, I love this thing. Because all those people talking about incidents and prevalences and etc., they're standing still. We have to do stuff to stop pressure ulcers. And Rove said it so nice. We know how to avoid pressure, bed sores, and tissue necrosis. Maintain the circulation, avoid long continued pressure, abrasions, extremes of heat and cold. Maintain a favorable microclimate, avoid irritating fluids and infection. The problem is the logistics of this. I love that. This is written in 1618. Thank you.